Okay, continuing with chapter 14, we're going to look at concentrations and dilutions. Now, firstly, just a quick recap on concentrations. Remember, there's many different units for concentrations. The one we're going to be using most often would be molar concentration, where 1 molar is actually a mole per liter. There's other common units of concentrations as well. The one is ppm, which stands for parts per million, which is milligrams of solute per kg of solvent, and sometimes milligrams of solute per liter of solvent. And both are related, and the reason why they're actually related and approximately equal, because the density of water is 1 kg per liter. So because the density of water is 1, whether you measure in kgs, a solvent in kgs or solvent in liters, it ends up being the same thing because the density is 1. This only applies for if water is used as a solvent and if it's a fairly dilute solution. Okay, looking at the next thing, another common one I've noticed in industry as well is when you make up solutions, you make up percent solutions. Now, we generally make up percent by mass. For example, a 10% solution of sodium chloride means 10 grams of sodium chloride, and your total solution weight will be 100 grams. So that means you got 10 grams of sodium chloride and 90 grams of solvent, which would be water. Okay, now just to recap on the part on molar concentration. Remember that molar concentration, the unit is C, and C is equal to moles per liter. And if you have to write it as a formula, easy way to remember it is C is equal to N over V, which is moles on top and liter at the bottom. Right, at this point we'd recall that number of moles is equal to given mass over molar mass. Right, and the units for the number of moles is got straight out of this equation, m over big M, which is grams over grams per mole. And if you cancel and rearrange, you get mole as a unit for N. Okay, now let's move on to our first question on molarity. Okay, a quick analysis of the problem. I just underline the things that are relevant for me to solve the problem, okay? Remember, potassium fluoride is Kf. Okay, now let's think about the equations we can use. I can say I've got mass, I've got volume, and because I've got Kf, I can find the molar mass. So I've got mass, molar mass, volume to find concentration. Easy. I just need to write down the equations and then substitute into the equations. Right, now you can follow the working. You see that potassium fluoride is Kf. Looking at the periodic table, the molar mass for potassium 39.1, for fluorine is 19.0. okay, and the formula for potassium fluoride is Kf because potassium is in period 1 and fluorine is in 7, group 7. Okay, so concentration is number of moles over volume. We know the mass, we know molar mass, and you can just follow the working, and I think it's pretty straightforward from here. The only point you need to remember is that 320 moles I need to convert to liters. Okay, so I get an answer of 0.586 moles per liter as the concentration. Okay, I'd like for you to walk through this one. Okay, now we look at dilutions. Remember, whenever you do a dilution, it's the concentration that changes, but the number of moles before the dilution and after the dilution is the same. And you know number of moles is equal to CV, N is equal to CV. So what we are saying is that C1V1 is equal to C2V2. Now let's have a look at the example below. I want you to pause it right here and try and give it a try first before I give you the worked out solution. We have 2.50 molar solution of sodium chloride and 20 moles of that. So those two are related, that's why it's in red underlined. And then we're diluting with water to 3 liters, that's green, so that's something different. So now let's see how we can apply C1V1 is equal to C2V2. We need to find the green C2. Okay, now you can follow the working. You can see that C1V1 is what was underlined red, and then the green C2V2 is what's underlined green. We need to find the green concentration 2, that is a concentration after the dilution. You divide on both sides by V2 and that's what you end up with. You substitute the values. Remember, I converted the 20 moles to 0.020 liters. You need to do that so the liters can cancel off, and I end up with 0.017 molar. So this session covered the section on molarity and dilutions. Okay, so you need to know how to do it, or you can look at the textbook for further practice questions.